you how to fill in pages 9 and 10, or better to say how to make sense out of pages 9 and 10 in your notes for Unit 11. These two pages show you different types of organic reactions, and I'm just going to show you what are some of those types of reactions that have similarities that therefore might be easy for you to mistake for each other, and what to look for and how you see that printed in the notes. Good. So the first two have some similarities. Substitution and addition both start with hydrocarbon. So it's only carbon and hydrogen. But the difference is the ratio. In substitution, you're starting with a saturated hydrocarbon, whereas an addition only works for unsaturated hydrocarbons, because you need a double or triple bond present that can be broken open and then only leaves a single bond left. So that's one of the differences. In both cases, you are in both cases, you're usually reacting with some kind of reactant, often with halogens. But the products are different. In addition, you're literally just adding the two together and you get one product. In substitution, you're taking one of the hydrogens out and you're replacing it with one of the chlorines, but that means you have a second product. You're not putting everything together into one product. So that's a way how to distinguish between those. Then another two reactions that are somewhat similar to each other are combustion and fermentation. Both of them tend to produce, or often produce, carbon dioxide. But one major difference is that combustion requires oxygen. So that is a giveaway. And the only products in combustion are carbon dioxide and water. So these two should be the only products if you have a full combustion. For fermentation, on the other hand, you might have carbon dioxide as a product, but your other product will not be water. And there is no oxygen required for this. So that's how you can distinguish between those. And then we have esterification and saponification, and really the only thing that they have in common is the end of the name, fication. And the front part of the individual name tells you what comes out of it. So in esterification, you're getting an ester, which you see this name, if you compare it to table R in your reference table, the fact that you have something ending in YL and then the OH or anoate ending, that shows you that this is an ester. So in esterification, you get an ester as a product. If you want to memorize a little bit more, to make an ester, you need an organic acid and an alcohol, and out of those two molecules, a water molecule is split off to make that connection to make the ester. Saponification refers to soap. So I have not seen any questions where they give you an example of saponification, ask for what is it, without telling you that this is a soap, that you get the soap as a product. A soap is, or the types of soap that they use here, is a salt of an organic acid. So think of this a little bit like neutralization. You have something that has an acid part to it. In this case, they actually use an ester, and you have it reacting with a base. Now, because you're not starting with an actual acid, but with an ester, you're not getting just water, you're getting um, alcohol, and you're getting this salt of the acid. All right. So this would actually dissociate into ions with this whole big structure here having a negative charge, and then you have the Na plus, but they show it as the salt compound. Good. And then the last one, polymerization. Um, if you think back to the Kloop lab where we looked very briefly at polymers, it's where the same or a few of types of molecules join to form really, really long chains. So you have many, many of those molecules together, and the exact number is not always important. That's why the coefficient here is just shown by a number n, and then once they're together in the chain, that n becomes a subscript because that is repeated so many times, but it's part of the same molecule. So that's how you can recognize a polymerization, because it always has this feature here with the brackets and repeated part. So that this is repeated and bonded to itself over and over and over again. All right, and that finishes the unit.